Thank you everyone for tuning into the Rafe YouTube channel. So Rafe is a Kubernetes operation platform, and we do a bunch of different things for the platform engineering teams around service mesh, GitOps, policy enforcement, access control, and we will be recognized as a cool vendor in 2023, and that's a great news for everyone within the company. And we also recognize as the number one platform leader in GigaOM reports for this year. And we all know if you are actually loving our services, I definitely recommend you actually grab the link from the description and actually do vote us for the DevOps Day. DevOps Dozen Award for the platform of the for the number for the, under the category of platform engineering. So definitely encourage you to folks do it. But we will speaking about our new open source offering today, and that's called Brave. We have another tool that is a year old now that I will be a part of. I mean, we have some sort of wonderful community building up that's called Parallels, the Kubernetes Access Manager. But now we're really excited to actually donated another open source project for the community that's around bare metal provisioning team. And one of the mind behind and the person who actually created a repository, documented everything, and came up with the idea is with me today. So let's go back to Robbie Gill. And thank you very much, Robbie. You will be on the screen and everybody watching you. So can you introduce yourself to a little bit about your experience and some motivation behind your our open source tool, Brave? So over to you now.
Sure. Yeah. Thank you, Sam. Yeah, my name is Robbie. I'm Senior Director Engineering with Rafe. Yeah, this is my first time live streaming with Sam. So yeah, thank you for having me. I guess if we talk about motivations, right, of open source tools, usually we are all as developers very heavy users of open source technology, and we can see firsthand how helpful and sort of it makes your life so much easier. So we just wanted to contribute back to the community when there are a bunch of problems that we face internally while developing various features and various products within the company, and we end up developing tools to solve those problems. And this is, I guess, one of those tools that we thought would be very useful for the wider community, and we just wanted to share, not just the tool, but also the thought process behind it, and perhaps get the community to help us take it to another level, right? So it's a foundational tool. It's a ground level right now, and but we have tried our best to make it as extensible as possible, and present it to the community, and hopefully they find it useful.
Yes, absolutely, absolutely. So let we can actually walk through on some of the things we actually prepared today for the audience, and we definitely had some wonderful demos we actually showcased to our peoples today. So I can share my screen and we can actually walk through the some of the because some of the folks are might be really new to these whole things, bare metal. They wanted to understand better, like why do we actually need this thing? Is it for mandatory for them to learn about these things as well? So as we speak about, so I'm actually working in their office system as a developer relations manager, and Robbie is introduced himself as a he's working as I'm really fortunate enough to actually work with him and learn a lot of new cool things from him every day. So Robbie alongside with me. So let's walk through some of the actually agenda I've actually prepared today. So basically, we will walk through you to what is bare metal provisioning, like why do we need it, and then there are some particular enterprise challenges associated with it, and then we tell you some of the what is Brave actually is, why it is useful, which use cases and which scenario you want to try it out from today. And next, we will talk about some motivation of the application of the project and some of the challenges we face. And we will see that community are also facing it. Why not we give it to the community so broader community actually can solve those challenges from this solution? So, Robbie, first thing first, can you walk us through as a starter, if what is bare metal in your eyes, and what are the bare metal servers?
Yeah, so bare metal is like, nowadays I guess everybody's used to going to a public cloud and firing up an instance, right? So that is not bare metal. That's the opposite of bare metal. That's a virtual machine. That's an instance that's running on some sort of hypervisor. Means that when the instance is created, you already get an operating system installed on it, and the stack is ready for you to connect. But bare metal is usually, yeah, just the nuts and bolts, just the hardware, sitting there in a rack, and yeah, that essentially is bare metal. Like, so you have to bring up the entire stack, including the OS and the applications and the network, all the way up to sort of for it to be a useful sort of compute environment for you to work on. So that's essentially a bare metal server, right? So purely just a hardware, not no software on top of it.
Yes, absolutely. So I think like bunch of folks when people are working on the virtual machine, they kind of came up with the idea we are actually virtualizing the hardware and then we're running operating system on top of it. Let's why not we can actually virtualize the hardware with nothing installed on it, and let's give it to some users. So then they basically took charge of these hardware machine, and then they could bring in new innovations or new software install on it. So basically they can actually sell out these machine to the larger audience, and then they basically consume those machines for running application, for operating system, and different kind of needs. So I think now we can walk through like why you think businesses as of today and in the past actually sees the need for embracing bare metal services servers.
Yeah, typically these are used in, you'll see it in private data centers where the corporations or the data center owners want more control over the perimeters of their compute resources. So public clouds typically, are a shared environment. I mean, there are feature sets available within public clouds where you could cut out your own tenant, but still the ultimate sort of the enclosure that for corporations, if they want to be very wary of their privacy, is usually a data center with bare metal servers installed. And typically, on top of that, they would install some sort of OS management system, be it some sort of virtual machine management like VMware, or it could be some Linux based OpenStack, or something similar. But the concerns tend to be usually around security and also around performance. So sometimes public clouds don't allow you direct access to the underlying hardware. Especially with the advanced networking requirements and advanced compute requirements like GPUs, etc. These are some of the use cases where bare metal use cases seem to make more sense.
Yes, absolutely. And I think the list is, as you show, like you can bring in some isolated space for your environment. And sometimes you want to don't came in the situation where you conflicting with the existing infrastructures and need with the different organization and different teams in there. And they actually came up and actually start fighting for the resources. So want to avoid noisy neighbor issues. And then we have a flexible administration and server configuration, because a team who are owning the bare metal infrastructure, we can give them isolated environment so they can manage, they pick and where those applications are running and how we actually consuming those bare metals. Instead, you have one main infrastructure where three different teams actually using it. It's become a complexity to solve those challenges. But as the list says, like these are the reason actually we are adopting it. But as you're adopting it, you will also noticing some sort of challenges, or you might call it disadvantages or challenges. And Robbie will walk us through to the journey, because we have also faced some sort of cost related challenges, and then we actually derive conversation towards how do we solve those challenges. So Robbie, can you talk to us through about the typical challenges you often see working with bare metal provisionings?
Yeah, of course. Some of the drawbacks of bare metal deployments are essentially around, lack of flexibility in terms of it's not an API call, right? Like you can't just make an API call to the public cloud and have the VPC come up, the network stack come up, the storage come up, the virtual instance come up, right? Like all of them are in a public cloud API call away. Not the case in the bare metal, right? So you will have to spend and invest in either specialized gear um, or some sort of API management layer locally to have the same sort of flexibility that you would have within a public cloud to deploy the same resources. And then it's essentially you don't have that much control around cost as well. So it's not pay as you go, right? Like you can't just use the compute and the network resources as you need them and then keep scaling up flexibly. With bare metal, you have to make capital investment upfront. So there is a substantial cost barrier in terms of if you want to do large scale deployment or you have many teams that are working on essentially research development or non-production use cases, then justifying that cost can be quite hard because it builds up very quick, and there's an upfront capital cost involved. Those are some of the bigger issues, and I see you have a few other listed over there, Sam. If you want to walk us through the rest. Yeah.
Yes, absolutely, absolutely. As you mentioned, I think like I think as you work longer with these infrastructure need, I think one thing you actually start noticing is that your resources become underutilized, and that's happen very often. Like, right? It's thankfully that's not an is currently there's no AI tool who can detect you. There are underutilized resources. You have to need to actually make sure the machine that actually you virtualize has 90% or close to 90 or 100% of utilization. But sometimes you're running application, a tiny megabyte of application with the GBs of data and GBs of CPUs and memory and all these things actually happening for. So that's the one thing. And also I think with the longer deployment times, because it usually takes a longer time to provision better bare metal server than virtual machines or even on cloud instances or even in containers. So it's take a huge amount of time. So you have to sometime. I think right now the currently you have some very intelligent bare metal services that can actually spin up in a few minutes and few hours. But long before the time, I think it took even entire day to actually spin up the bare metal infrastructure. Then there is a hardware maintenance is one of the biggest thing. I think it's one of those challenges we actually need to know. You have to set up a team, entire team dedicated to it, see how the hardware actually working, and then as you mentioned the higher cost and plus the complexity, and that complexity is around provisioning knowledge, how you actually provision the resources plus the hardware maintainers. And for those skills may be a shortage for some of the organization. You don't have expert who can actually be a hardware expert in your company, and you don't have enough knowledge for the provisioning need of the bare metal. So those are also challenges associated with it. So now we can circle back to a conversation here. What is brave? And then we speak about our own challenges that we have faced, and then seize the need that how we actually solve those challenges. And then we generated our project to the brave, and then I walked through to the our GitHub repository as well. So Uh, Robbie, over to you. Can you tell us a little bit about story, how we came up with this solution, and what it essentially does today?
Yeah, like I mentioned, Brave essentially came out of an internal project, right? So a few months ago, we were at Rafe, we were trying to add Kubernetes operation support for uh, upstream bare metal project called EKS Anywhere Bare Metal. And as you can imagine, the first requirement for R&D and development on that project was some capital investment in procuring some hardware, bare metal. And that particular project had, very specialized requirements from the bare metal in context of the hardware required for it. So there was certain hardware that was, qualified by EKS, and they had a list online, but the besides just the servers, there was also investment required in the BMC controllers, which are the power management controllers, right? To automatically power on and off those servers on a network. And essentially, you also have to set up your, sort of network. It has had very sort of specific networking requirements as well. So overall, from a production perspective, if you are, sort of rolling out a production cluster, that makes sense. You would go ahead and, make the investment and, use the recommended hardware. But since we were essentially trying to develop a product that implemented a workflow to sort of enhance the existing functionality, we were mostly interested in research and development angle. And we wanted to set up, testbed environments, lab environments, demo environments, and it just seemed like there was sort of no good way of procuring the hardware, and the only the model that seemed to work for some of the folks that we talked to was setting up a shared lab and VPNing all your developers and all your sales staff into it for doing demos, etc., and schedule something using a calendar so you could share access for the same computer resources. So that was becoming a bottleneck for us, given the size of our development team. So we started thinking of alternatives, and of course, we started going in the direction of hosted bare metal providers, but so we were coming from our experience with the mostly public clouds to these hosting providers, and we were expecting you turn off an instance and you don't get charged for it. That's usually not the case with bare metal providers. So the meant that the development environment that somebody fires up um, keeps accruing cost for the over the weekend, overnights, and so within our small team of developers, within a month, racked up a sizable hosting bill, and so that was obviously not sustainable. So we started writing these tool sets that we could we started experimenting to see if we could virtualize the network setup and the bare metal servers, and also the power management requirements, and set up some sort of on-demand lab or a testbed environment for us to do R&D and development with. And the engines underneath that we started experimenting with were essentially Vagrant and VirtualBox, and this was essentially the birth of Brave, and it essentially uses these tools along with Terraform to simulate bare metal environment for any sort of application. And in this case, we were building the workflow for EKS Anywhere bare metal Kubernetes cluster. So we set up a virtual uh, network to connect all the virtualized bare metal servers that were simulated using VirtualBox VMs. And then we wrote a custom provisioner, which was essentially um, monitoring the state of the EKS bare metal cluster to do the power management automatically, so that there was no need of a BMC controller. The power management was simulated using VirtualBox, VM power off, power on. But it was being run by the tool Brave by monitoring certain conditions within the Kubernetes cluster. So yeah, that's a brief summary of it, of the history behind it, and how we ended up sort of developing it.
Yes, absolutely. So now, Robbie, I think if folks actually watching us and if you have any question, we'll look forward to the community question on the chat as well. And if you have any question, please share them on the chat or in the YouTube description or on the YouTube comments box as well. So definitely want to see how people are actually using bare metal services and what are the challenges you are actually facing. So we'd love to spoke about those as well. So now, Robbie, can you actually walk us through? I see one of the video is also in where it is available in this. So, is how best people can install this tool? What happens, and what is the way to actually test this tool?
Yeah, sure. So I guess I wanted to just touch up a little bit on the applications of it as well, I guess, before we jump into too much of detail. So we obviously started with the development and testing environments, but as we started progressing with it, we started noticing that we could actually use the same environment for our CI/CD pipelines as well, right? For automated testing. And we were also interested in figuring out some of the protocols that were being used for essentially bootstrapping these servers over PXE. So from a security perspective as well, we were able to do an assessment using a purely virtualized environment. And the same was true for disaster recovery testing. So we were able to simulate the DR scenarios in a virtual environment and see how the software was sort of recovering automatically, or was there any workflows that needed to be enhanced. Um, so as you can see, many of these are non-production use cases, right? And in similarly, there could be like a scaling infrastructure testing that you could implement as well, using the same virtual setup that we just talked about. And again, like once the product is ready, you would want to educate, train, and do demos, for a particular application that's running on bare metal. And for that as well, this could be a good application. But yeah, these are the few use cases that came to mind. And then so we'll start work going through the videos. Do you want me to share my screen, or how
I
does that
think
work?
got it. I think can you? I think I can use my screen instead,
Okay, sure.
and you
So
can basically walk us through.
can you go through the video link? Actually, this is just a small one. So if you go back to the docs, the repo.
Yes, sure. I'm currently showing the YouTube video. This one. This is bare metal EKS cluster provisioning.
Okay, sorry. Yeah, I thought you were. Okay, yeah. So this is yeah, walking us through the configuration file for Brave. So we support two providers right now, public cloud providers, which is OCI and AWS. And this is extensible. I guess, we can add more public clouds as well. But then there's a third provider, which is Infra exists as well, which essentially means just above it, just above it. Sorry, Sam. So if you scroll, yeah, just underneath OCI, there's Infra exists. Yeah,
This
yeah.
one?
So just below it. Yeah.
Okay,
So
okay.
yeah. So infra exists essentially means that if you already have an instance up and running in virtual cloud, then you can just give us the SSH information, right? And we'll just connect to that one. Um, so it might be better if I can share my screen so I can control.
Yes, sure, sure,
Yeah,
absolutely. I think that would be easier for you. Yeah, sure. Can you
yeah,
share your screen now?
sure. Just 1 second.
And between, well, Rob is sharing his screen, we wrote a blog about it with all the details in here, things we're describing. You're going to read about it. And then we actually tell you some ways how you can actually fork the repo, use it. And if you have some question, how do you actually communicate back to us via our parallel Slack channel as well? And those who actually recently joined or joined late, here is a link for our repository. uh, and basically, if you like it, I would definitely love think you have to vote it. And if you have some question in there, to feel free to talk about as well. So Robbie, now you can share your screen so I can add you to the stage. Yes, I can see it. Good.
Okay, yeah. Sure. So yeah, so we were talking about the input.yaml file, right? The configuration file. So this essentially walks you through all the elements that you can configure and to make Brave sort of work with different public cloud providers. And once the instance is up on the public cloud, what other sort of provisioners that you could use to provision various bare metal applications on it. So we support 3 infrastructure providers. This OCI, sorry, yeah, yeah, there's OCI, and there's AWS, and then there's InfraExist. And InfraExist essentially means that, like I said, you have SSH credentials to connect to that instance, and then exists in some public cloud. It could be any. So this is like a catch-all. And then we support provisioners, right? So provisioners are essentially the use cases, right? So once the public instance is up, what do you want to simulate on it, right? So there is, like we were talking about, EKS bare metal clusters. So this is one of the provisioners is EKS bare metal cluster, and then we have another one with the EKS bare metal using Rafe, and then there is generic VMs only. If you did not want EKS VM, but you only wanted VMs, right? So if you wanted to add, so then you just, after you've configured your input file, you can just run Brave, and then it'll just essentially process each configuration item in input.yaml, and then use Terraform. It'll decide which cloud you're trying to provision, provision the instance on, and here it detected OCI, and then it'll essentially launch OCI instance, and Terraform will keep going on. Go forward a little bit. Yeah, see, so Terraform is complete now, and then it essentially figures out what the IP of that instance is, to essentially needs that to SSH into that instance and run the rest of the provisioner. It also adds the SSH config for the instance hostname locally, so that you could just, from that point on, you can just SSH and the name of the instance, and you could access it directly to it. And then it just runs a bunch of steps to install few softwares on top of that instance to bring up essentially VirtualBox and Vagrant on that instance. They'll install all the required packages. So here's where the execution starts of the provisioner. So essentially, it will detect which provisioner you're using. We're using a EKS VM cluster provisioner, and then it'll process the input.yaml to see how did you configure the Kubernetes cluster parameters. So in this case, we configured the Kubernetes cluster to be to have two nodes, one CP node and one worker node, so one control plane node and one worker node. So it'll essentially create all the VMs that it needs for creating that EKS bare metal cluster. So in this case, for EKS bare metal, you also need an admin machine. And so there will be a third machine that will create. So we'll end up creating three VMs, one EKS admin VM to simulate that admin bare metal machine, and two servers, one for control plane, Kubernetes control plane, and the second one for a Kubernetes worker. So it'll take a little bit of time, but it's doing a lot of the heavy lifting. And it'll also create the network. So in this case, it's creating a NAT network, so that all the three machines, the EKS admin machine and the control plane and the Kubernetes worker machine, can see each other on layer 2, so it can PXE boot. And also they can access the internet at the same time. So that would also be set up here, creating VBox network. And then it creates admin VM next. You'll see it's creating the admin VM. And then we'll create all the control plane VMs. So if we had specified more than one, it would have created all, 5 or whatever number that you had specified. And then it creates the data plane VMs. So here it confirms, right? So the cluster name from the configuration was Brave. The version that was specified in input.yaml file was 1.27. And the number of control plane nodes was 1. And the number of data plane nodes was 1 as well. And here it will start essentially creating all the files that are necessary for provisioning. Essentially, you need a hardware.csv file for EKS bare metal, which is the specifics of the hardware servers, their MAC address, their IP address, and the storage information and the DNS server information. So Brave also does the IP allocation. So it does the IP management. So it will allocate IPs to these VMs and manage the IP allocation. So it'll make sure these VMs have statically configured network interfaces. So they always come up with the same IP. And here's the hardware.csv file that it generated for the cluster. And then it'll generate the config.yaml file for the cluster, which is the EKS bare metal, configuration file. So I won't go into too much detail, but yeah, those familiar with EKS bare metal, they'll see there's various IPs, Tinkerbell IP and Endpoint IP, which is, the IP management side of things that it's doing for you automatically. And then it's installing a few other tools that it needs to create the cluster, like the EKS CTL CLI and kubectl CLI, and installing Docker automatically on admin machine. And then it's created the cluster using EKS CTL CLI, using anywhere create cluster. But and then it's monitoring the state of the cluster from that point on, to see what changes are happening, and then it takes actions based on that, right? So it's monitoring the cluster creation logs for is a certain state, which is like creating new workload cluster. So it's going to wait until that, and it'll, once it detects that state, then it'll move on to the next. So keep monitoring, keep waiting for 60 seconds and come back and then look at the logs again. And once it's noticed that that state's reached, which it is now, it will start doing the power management. It'll execute the power management logic. It'll start powering on the worker nodes and the control plane nodes one by one. So it does that by, there's an algorithm that's in the documents as well. There's a flow chart that we can go to later. It essentially just uses that to figure out when should it power cycle which machines. So that this is the part which is, managed with the BMC controllers in a production bare metal environment, and Brave is just simulating that behavior by monitoring the state and the logs of the cluster in the simulated environment, and then using essentially VBox manage power off in the back. And it'll just keep doing this until all the nodes have gone through PXE boot and they have been provisioned successfully.
Yeah. So,
So
Robbie, one quick question here is, let's say we saw like we have a brave.sh, like that's file, the script you actually run. So that's a step number one. You wrote as you can write, you can actually run a script. So after that, so that's one script has all the parameters in there, or is it a some way that if somebody wants like customization or can pass a parameter via command line on the fly, so to, let's say, to change the IPs, or let's say change the port or SSH based on their need, so can this workflow be supported today?
yeah, it's essentially written in Python, right? So it's a Python sort of software, and all the configuration parameters to it come from a single YAML file, input.yaml. So any custom configuration items that you wanted to pass to Brave, and you wanted the provisioner to take those in, you could sort of keep your configuration items in input.yaml and extend the YAML, to pass those in, and modify the Python code to use those. Now, if you say wanted to run, you're not interested in EKS bare metal clusters, right? So if you
Yes.
wanted a completely different use case, say, we have another example use case of just bringing up VMs using the provisioner of VMs only. That will just bring up VMs. It won't do any of this cluster provisioning. There's no, not Kubernetes related. In that case, you could use that example provisioner as your starting point to write your own provisioner to your use case that you want to, want those VMs to sort of perform, right? So the underlying base that Brave builds up remains the same. The VMs need to come up simulating the bare metal servers. The network needs to come up. They all need to be connected to the same network, so that they can, communicate with each other at layer 2 and above. And they all have access to the internet. So they are able to, pull software from wherever they need, do, app gets, OS installs, or whatnot. And from that point on, you can customize, what you want those servers to do now. Do you want them to, build a Kubernetes cluster using these instances, or you just want to build, some other sort of clustering environment using those VMs. So these use cases are quite open, and they're only as far away as essentially writing another provisioner. So the framework allows for extending it to add more and more provisioners. Um, so one of them, that we implemented end to end, showing the power of, I guess, the framework, is EKS BM and Graph EKS BM for Kubernetes clusters. But then you could use them as a sort of starting point to write your own provisioners as well, and all which provisioner to run and which public cloud to bring them up on. That's all controlled through that input.yaml file. So it's quite flexible.
Yes, absolutely. I think that's a workflow is really, I think, easier to go through. So basically, all the things you actually add in the input.yaml file, and you can write a provisioner to support that use cases. So meaning you have a one script and one configuration in place in order to support or extend the extensibility as well. So Robbie, I think it would be great if you can actually walk us through on the Git repo as well, like how the Git repos are structured, and if they clone the repo, if they write a provisioner, where the provisioner information is currently located, and if somebody create a provisioner or extend some kind of extensibility, where in the repo they can actually go through. That would be a good one to actually wrap up the conversation.
Yeah, sure. So maybe just to kick off the conversation, I'll walk through like an example input.yaml file in a little bit of detail. So the infrastructure providers are, is the first bit of configuration that you need to do, right? So it comes inbuilt with AWS and OCI, of course. Under AWS, it'll, the configuration parameters that you need are essentially these. They're, it assumes that it'll have to, nothing exists, right? No infrastructure exists, and you'll have to, it's start from scratch. So no VPC exists, no subnets exist, no infrastructure exists, right? So these are the assumptions. So if you need to change that, if you say you needed to use an existing subnet or an existing VPC, you could easily make that change in the TF code, Terraform code, right, underneath, which is under the Terraform registry, and it's structured essentially under TF AWS, and it's just Terraform files, like you can see, and OCI as well. It's a Terraform file,
Yes.
um, and
Uh,
same. Yeah, go ahead, sir.
Absolutely. So are you sharing a different screen, or you actually let me? I
I'm
think
sorry. I thought I was sharing the screen. Let me share.
no worries, no worries.
Uh,
Or even I can share. No worries. On the let me do it. Yes, so I hope you can see, everybody can see the Git repo currently where I'm actually is in. So Robbie, I think we can spoke about like what's in the cluster config. Like these are related to the
sorry, not this one. Can you go back in the main um, Brave doc?
uh,
So and then under docs,
yes,
there should be an input, um,
input. Yes,
and
this one.
then input.yaml. Yep, .md. So this is, and then there should be a full example right at the end. Yeah. So this walks you through of all the details of how you structure your input.yaml file. Yeah, here, this one. Yeah, complete example. Yeah, if we could stop
Yeah.
here. So this is what I said, essentially I was going through. My apologies. I thought I was sharing, but
No,
of
no.
course not.
So basically,
Um,
if there is new need for the infrastructure provisioning, so basically they need to give us these values or
yeah,
add the configuration of file in this
yeah. Or
configuration.
if they want to enhance the existing AWS or OCI, this is essentially Terraform. All right. So
Yes,
you could add more Terraform parameters underneath here, and then change the Terraform code under the TF directory on the left, if you see uh,
this one.
in the directory structure. Yep.
Yes,
So here there's a AWS folder, there's a OCI folder. So you just create another folder for your provider, whatever cloud that happens to be, Alibaba or whatever, right?
yes,
And you could write that Terraform code there, and then just uh, add another section in the input.yaml for that provisioner, right? So that's the Terraform part of it. So it does assume right now in its current implementation that no infrastructure exists, right? So that may or may not true. Say, like I was saying, you might want to use the existing VPCs. You might have a restriction to use some existing subnets. So those changes can easily be made. But right now, just for the ease of use, because the common developer use case is nothing exists. I have nothing, right? So take me to from 0 to 100, right? In a click of a button. So that's the use case that it's by default the behavior is. So that's for the public cloud bringer. So if you scroll down a little bit in that configuration, yeah, just above a little bit, yeah, yeah, scroll. Yeah, these are talking about public clouds. I just wanted to show the provisioners, the EKS VM and um, the VMs only, right? So there's a complete example there, right there. So it says provisioners VM only, right? So that's where the selection of the provisioner is happening. So underneath the provisioner config, you can see there are actually three provisioner configs, right? There's the VMs only provisioner config, and then there's a EKS VM cluster provisioner config, and then there's a RAFA EKS cluster provisioner config. So these are essentially the workflows. Once the VMs are up on once the public cloud instance is up, and then VirtualBox and Vagrant has been installed, the VMs are already up, the network's already up. Now what do you want to do with it, right? So that's what the provisioners control. So yeah, these are the example provisioners that exist today. If you want to implement another provisioner, you would just give it a name and specify the configuration underneath it, and just point to that name in the config file, and that's pretty much it. Uh, Sam, you're mute. I can't hear you.
sorry, sorry. I'm saying like that's if folks are actually listening, this is a great developer experience things in here. Like we have one place you can actually write a configuration, and then you create a folder with your provider, and then the things working as it, and then you run a brave.py command and the Python
Mhm.
command to spin up everything behind the scene for you. So you can pass the parameters or configuration in the input YAML file, create a folder or provider in the TF folder, and then create a new provisioner as you wanted. Give us some configurations, uh, how you want to set it up, and then it's boom. Just run the brave.py, something happening behind the scene, and you don't need to change often. So it's a very flexible and reusable structure, if folks are actually familiar with. So I think we have few more few
This
more minutes
yeah,
left.
it installs tight VNC as well, right? So I think if you're thinking from debuggability perspective, right? So maybe we want to touch on that a little bit as well, because
Yes, absolutely.
um, the type VNC is in there so that you can use the consoles of these machines, right? So you can log into the virtual console and you can see what's going on in the VMs itself. Well, if there's a problem during bootstrap, during bring up, or some network problem happens, or say if there's also tools available to manage these VMs. Say if you started off with 3 VMs, 4 VMs. Now you want to add more, or you want to delete some of the VMs. You want to add another network, or you want to delete the network, or you want to do like sort of day two operations, right? So there is a bunch of scripts that are pre-packaged with Brave, so you could just and they are automatically copied over to the instances, so you could run them, and then sort of you can create them to launch more VMs and whatever your day two operations with the VMs would be, right? And yeah, you're sharing the right screen. Yeah, there is a type VNC server pre-installed, and you can use a VNC viewer to just VNC into the cloud instance. And I use SSH port forwarding, right? Because it's just a little bit more secure rather than opening the VNC port. So connect over SSH, and then you can see your normal VirtualBox UI there. And if you double click on any of the VMs, you see all the console messages. And this is very, very useful for debugging. Like there's a number of times an instance just doesn't want to come up, right? Like, what happened? Or some weird error happened because you ended up specifying some wrong configuration parameter, and the workflow timed out. So these debugging tools are very useful, and day two management. So you did bring up the infrastructure today, but say if you want to make modifications on the fly for day two, those are possible as well.
Yes,
And
absolutely.
And another thing that is built into the framework is when if the ability to stop the the entire infrastructure and essentially make it follow the public cloud cost model rather than the bare metal cost model. So because it's a single instance, everything's on a single virtual instance. Once you're done with your test bed, you could stop it, right? So it'll stop charging you money, and then when you restart the instance, it will automatically bring up all the VMs that were there and the network, right? So that's already built into the framework.
Yes, absolutely. So I think like if you want to destroy all the things you actually work today, or let's say created a POC for all these things, you just need to run a delete.ipy command, and everything is created is just deleted and be back to the normal position where you are.
Yeah, it will just run a Terraform destroy and then just rip everything, and then it will. One of the provisioners is also written with the Rafe integrations with the Rafe console. So it will, if you are using that particular one, it will also log in into your Rafe console and undo all the elements that you had created or the objects that you had created. So it'll
Oh,
delete the cluster, it'll delete any gateways you created, it will delete any credentials that you might have created um, using Brave.
yes,
So
that's
it
a very neat
cleans
feature.
up.
Yes, that's a very neat
Yeah.
feature. Absolutely. So basically, I think we can spoke about most of the thing on the call today. But is there anything left and the final note for the people who actually look it out, tried it out, and if they want to actually meet us, I will definitely want to actually want you to actually go to the Sparrowless Slack channel under the Brave channel. Definitely want to ping us as well. So as Robbie, we're actually closing down this year. This might be my last stream for the 2023 on the Rafe side. So let's talk about what's the near future for the Brave in the next few months and then in 2024.
Yeah, so we have a few other use cases that we have in mind internally for other cluster types that we see it, making our automation pipelines much more easier and making our sort of life easier in general with in terms of the all the other applications that we talked about like demos and sort of doing these security analysis and scale and DR testing. So those are the use cases that we are sort of trying to integrate this tool into, and as we develop more and more of those, we will keep contributing them back to the community, to the project. um, that's yeah, the future's looking bright for Brave for now. We will continue working on and expanding it.
Thanks, Ankur, for your wonderful messages. It's great to see folks are actually watching us on the LinkedIn and other places as well. So thanks once again, Robbie. It's been wonderful talking to you. Don't want to interrupt you because we have a time limit constraints here, but definitely I'd love to speak more about with you this tool because it covers broad range of use cases as well. But so I think this will be a first step for the people who wanted to extend the existing functionality and I wanted to move on with this it. So try out, go into the Git repository of the Brave and just ping us like what you want to extend. We walk you through some of the customizability options we have and how you can extend it. And we definitely write a blog post about it, what various use cases that it solves today. But particularly, we definitely have some wonderful roadmap coming ahead. We'll try to prepare a roadmap and share it with you in the repository. So we basically look where the direction is going, and that's the open source tool are basically for the community. We want to see how people want to use it and which direction and which challenges they want to try to solve out. So with that, thank you very much who actually tune into this channel for 2023. We managed to cover, I think, 13 and 14 live stream this year from the KubeCon Amsterdam to the PlatformCon, and then we KubeCon Amsterdam, some AWS reInvent talks, and bunch of other things we covered on this YouTube channel. So looking forward to seeing more and more attraction coming for the 2024. Thanks, Neera, for your comments uh, and 2024 we have to see more and more interaction going forward. So with that, it's a great year for me and for a bunch of our colleagues in the RAFE. We managed to become a cool vendor in 2023 and number one for the platform leader in the GigaOM report for this year. These are the best two things we actually achieved, and looking forward to achieving more. And if you're actually watching this, grab a link from the YouTube description and do vote us in the DevOps Dozen Award for the best platform in the platform engineering category. If you actually watching or if you're actually consuming our services, thank you very much. Stay safe, stay healthy. Wish you a very best luck for everyone for the next year. And we'll be meeting you soon in the next year with a bunch of other live streams and a bunch of other open source offering. With that, Robbie, thank you very much. Enjoy really talking to you today. And we'll meet soon. Bye bye. Stay safe, stay healthy,
Thank you very
everyone.
much for having me. Thank you, guys.